Morning girls. So today's question is oblique planes 9. So you'll find it in the same PowerPoint that we've been working from. So that's in files and it's called the oblique plane and it is slide 26. Okay, so if you're printing out, print it out. If you can't, you can trace it as big as you can. I've done something similar and I've traced it out. What you need to do for this is determine the traces of the oblique plane that contains the surface A and then determine the true shape of the board. Then you have to insert this design on your drawing. Now, it says it needs to be a diameter of 35. Now, I'll talk about that again when it actually comes to the question. This is meant to be on an A3 sheet, so obviously a diameter of 35 possibly won't fit on your sheet. You might have to do a diameter 25 or 20, depending on your actual, how big you drew it. So this is a sandwich board and you see them outside cafes and restaurants quite a bit. It is a triangular shape. So I'm expecting that when you look in at the side of this, you're going to see a triangle. But if you're looking at just surface A, it's going to be a rectangle is the true shape of it. The first thing we're asked to do is get the traces of the oblique plane. And this should be straightforward enough because we have 2 points on the ground. Okay, so I'm just going to show you the question as is. You either need to trace this or print it out, whatever works for you. When you have that done, so I have my drawing here, I have the sandwich board, plan and elevation. Now these 2 points are on the ground, and if you find those 2 points in plan, you will find 2 points on the horizontal trace. Okay, so the horizontal trace is where the plane touches the ground, and we have 2 points on that already. So the 2 legs of the board, so the 2 legs at the back are here. So it's the 2 end points you'll be joining to get the horizontal trace. Just make sure that your ground line is long enough, because the issue you will have is obviously if it isn't long enough, it won't intersect. So continue on your ground line long onto the left hand side, and you're going to join the 2 end points together and create the horizontal trace. Now this is a heavy line. I just noticed in some of the questions that you've been doing, you've been drawing them kind of light. The vertical and horizontal trace, it's a plane. So where it touches on the ground is going to create a line, and that is going to be heavy. So this is a HT, horizontal trace. And again, it's the 2 end points. These are on the ground. So there are 2 definite points on the horizontal trace, and you just continue it on. You have seen this time and time again. If I want to find any of these points in elevation, usually what you do is you bring them parallel, up vertical until it touches on your VT, and across in order to find its actual position. But now that we have its position, I can work back in reverse. I can bring this across, bring this up parallel and see where it intersects, because that then will have to be a point on the vertical trace. So we've done this a few times. Now, we've 2 options, and I'm just going to label these vertices on the rectangular shape. So this is surface A, and it's just this shape, just that rectangle to the left-hand side. This is the back surface. That's a different oblique plane. So I'm going to label this like 1, 2, 3, and 4. And you can find any of those 4 points. You can bring any of those up parallel, up vertical, and across to meet them. But as I've always said to you, you're better off picking a higher point simply because of accuracy issues. If you choose the likes of 2 and 3, they're quite low. So I'll just reference these to the elevation 2, 3, 1, and 4. 1 and 4 are quite high. And as a result, it's easier for you to draw that line in afterwards. If you pick a low point, it's hard to get an accurate angle on it. So the higher up it is, the better it is. So with that in mind, I'm going to come parallel to the horizontal trace. I'm going to find point 1 is what I'm going to do. So bring 1 parallel to the HT, bring it up vertical. And normally you'd go up vertical until it touches on your vertical trace, but we don't have it at the moment. But what we do have is point 1 already. So just bring it across. Where the 2 of them meet, that has to be a point on the vertical trace. So draw it in, and again, this is going to be a heavy line, so make sure you put it in heavy and call it V, vertical trace. So you have your V, T, and H underneath. Okay, so we've part A of the question done, and that was, I'm just going to read it out to you again. So part A of the question was determine the traces of the oblique plane. We've that done. Part B of the question is to determine the true shape of board A. Now, we know it's going to be a rectangle, and there's a couple of ways of going about this. So yeah, you could rebat it down flat, but we can't do that until we get rid of one of these lines because it's inclined to two planes, so there's two angles going on. We need to get rid of one of them by creating a simply inclined plane. This is something you've done 3 or 4 times now at this stage, or even maybe 5 or 6 times at this stage. So with this plane, I'm going to continue on all the points parallel or in line with the horizontal trace. Okay, so bringing out all of them. Now you could just do that surface, but I'm going to bring out the whole sandwich board, bring out the back points as well. Doesn't really matter. And the most important thing you do when you do out here is you have to create a ground line which is perpendicular. So you're either going to slide your set squares, or I flipped them, as you can just see. I flipped my 45-degree set square to get an x1, y1. Where the HT was brought out and touches on the x1, y1, that is your HT. Okay, so that HT is now a point. We're getting a point view of it. And in an auxiliary, you always work from your last XY line back. So when I moved out here, if I work backwards, it goes into plan and then it goes back into elevation. So this is my last XY line back. So I'm taking heights. So what I need to do here is to get the height of 1 and 4, we just transfer the height, take the height from the elevation and transfer it into our new auxiliary. So 1 and 4 are the exact same height. So it doesn't matter if you take the height at 1 or if you take the height at 4, because when we look in there, 1 and 4 are going to be in line with each other, as you can see. So you can see out there now, I'm after finding the point 1 and 4. I haven't found 2 yet, but I will in just 2 seconds. If I join corner the bottom of the sandwich board to the top of the sandwich board, okay, that's the sloping surface. The leg is this long, so this point here is 2 and 3. And as I was saying to you, this is a triangular board. You see them outside shops loads of times. Okay, so that is the triangle. That's the other oblique plane. And I'm going to call this like 5, 6. Okay, now that we have that much done, in order to get the true shape, we rebat it around. That means turn it, bring it back into the plan position and find it underneath here. So you will see me kind of moving up and down my sheet a good bit just in order for you to see it. So I'm still concentrating up on this auxiliary for the moment. And I'm just going to continue on that XY line like you've done every other time. And because it's just surface A and this is surface A inside here, okay, I'm only going to rebat 2 and 3 and 1 and 4. They're the only things that are important for this. So rebat 1 and 4 around. Rebat means turn or rotate. Okay, so I've rotated both of those around. I've found them on the XY line. And I'm just going to ignore this for a minute by pushing this up. Okay, so you can see that I've turned 2 and 3 around. I'm going to label that 2 and 3. I've turned 1 and 4 around and it's now here. And you can see that, I can see. And now I'm going to bring back 1 and 4 and 2 and 3 back here. And I'm going to get the true shape down here in line with the plan. Okay, and you have done this a good few times at this stage. So it should kind of start making sense, I hope. This is another really good question to make sure. So I'm starting to bring out 1 and 2 and 3 and 4. And you'll see the true shape coming in there. It's just a rectangle, like nothing special. Okay, so the rectangle is just done, but I'm going to do it in heavy because I can see where it's going to be now. Now, so that's part B of the question done, to get the true shape of the surface A. And I've just finished that now. Okay, and I hope you can see that too. I'm going to push that out a little bit. Okay, so I've got the true shape. Still not finished though. So that's part B of the question. Get the true shape of surface A. That's the true shape of A. Next part. And I like this one simply because you're starting to use an auxiliary to transfer heights, and that's the second way of doing this. So we are asked, a design based on a star below must be placed at the centre of the sloping surface on a board marked A. Okay, so it has to be on the front here of the star. Draw the projections of the star. Now they're saying that the diameter of it needs to be 35, 35 diameter or millimeters. You might be able to fit 35. And the way you can see if you'll fit 35 or not is it will fit across the section there. Now mine, I've scaled mine up. Mine is 50, so 35 will definitely fit. But regardless what you have, so whatever your shape is, let's say it's 40 or if it's 30. If it's 30, maybe do 25. If it's 40, you can do the 35. Just whatever it is, just make it relevant to what your drawing scale is. If it's printed out, that it fits nicely in the shape. So you might change the diameter of it, and that's fine. To get the centre, cross the diagonals. Now I know some of you mightn't have your protractor. If you don't have a protractor, instead of doing a star, you could do a hexagon, and you can use your set squares for that. So that will fix that one for you. Okay, now that I have the centre point, and 35 is such a terrible number because it's a radius of 17.5. But anyways, you can edit it if you like to 36 or whatever is easy. Grand, and I think I might do that because it's very hard. Measure 17.5 mil. It's actually around 17.5. Anyways, draw the circle, and this circle is light. Because what's important in this question is the star. Okay, so I have a very light circle drawn. What I want is the top of the star to be upright. The top of the star, I want that upright. Bearing that in mind, the top of the star will have to be up high then. For that to happen, when I rotate that around, the top of the star, actually, the apex of it should be in this side. So I know a lot of you will start drawing the base horizontal, doing the whole pentagon thing going on, but that's not going to work. So simply because if you want the top of the star to be upright, the apex of it or whatever, that's up high. That means it needs to be up high on this triangle. So when you rotate around and bring it down, the apex is actually on the underside here, is there. Okay, so just be careful with that. So with that in mind, I'm going to ensure that the pentagon that I'm going to draw has the apex at the top there. And to ensure that, I'm just going to draw a centre line through the centre. I'm going to grab my protractor, if you have your protractor. If you don't have your protractor, you can do your set square. Slide your 30-60 set square and create a different shape instead. Now, I have to measure. And I'm just going to tell you the difference. 72 degrees, yeah. I can just do the 72 degrees on the inside. So put your protractor on the centre line just as it is here. Make sure it's dead centre. Okay, measure the 72. Draw it lightly in. Okay, when you have that, I have got the edge length of said pentagon. I don't really want the pentagon, I just need the 5 points on the pentagon. I don't actually need to draw it out. So if you take the edge length, that's the distance from the apex of the pentagon to another vertex. So take one of the distances and just step it off the 5 times. And you can see I'm working on this symmetrically. What I mean by that is I'm keeping this centre point as the main one. So I went left and I went right. I went from the new point down and from the other new point down. So it means that these are definitely the same distance apart, even if my accuracy wasn't perfect. Now that I have all 5, I'm going to start joining them together, corner to corner. So one vertex to the other vertex to get that star shape. Keep going all the way around. Still can't put this in heavy until I have the star kind of established, and then once I can see what's heavy and what's light, then I can do it. So I can see my star now. So I'm going to start putting in heavy what is definitely heavy and putting in light what is meant to be light. And you can see I'm just coming up to the star, whatever is important on it. Now, and I'm going to number this just so when I do transfer it back and around and so on, that I have something kind of to associate it to. It doesn't matter if you go A's, B's, C's, or 1, 2, 3's, completely up to you. 1, I'm calling the apex because that's the most important one. 2, 3, 4, and 5. Once you have your 5 points, I need to transfer this shape onto that surface, and then on that surface up into elevation. So I need to go through all of the views. Now, it's not just as simple as, oh, let's bring back these 5 points and let's bring them up. We have absolutely no heights. So we need to bring them back in the way we brought everything down. So the way we moved from this is we had the elevation and plan done. We moved to the auxiliary, we moved to the rotation, and then we moved down to the rebatment. So we have to work backwards. We're going to bring the 5 points back up into the auxiliary. So you're going to bring them and rotate them so you can get a height. You can bring them down into the plan and then across to find them in plan. Then bring them up and you can take the heights from the auxiliary to transfer them here. So there's a bit of work in moving those 5 points. And consistency and accuracy are so important. Okay, so labeling first. You've done the pentagon, you've drawn the star is what was important with that. And you put in the bits of the star that were meant to be heavy, meant to be light, so on. Okay, so parallel to the HT is how the points had to be slid. So you have to slide them back the exact same way. 3 and 4 should be in line. So that's 3 and 4. 2 and 5 should be in line, and they are. 2 and 5. And finally, number 1 is on top there. There it is. So I have the star moved, those 5 points moved to the base. In working backwards, I need to rotate them back onto the surface and then bring them down. Okay. So compass. Compass goes on the HT or XY line, whatever you want to call it. Rotate 3 and 4, rotate 2 and 5, and rotate 1. Okay, so it's actually testing a good bit of stuff, this question. It's going back over everything you've kind of learned about symmetry and that from first, second and third year. How to get the centre of a shape, how to draw a pentagon inside in a circle, and then how to transfer points. So we have 3 and 4, we have 2 and 5. Now in fairness, you mightn't need to actually write these in every single time. You might just know 1's on the top and do the other points from that. Anyways, if I was doing it myself, I wouldn't be labelling all those 5 points. You'd be able to kind of make it out. Anyways, so bring them back now. So I have them in this view. I need to bring them back into plan and then bring them up to elevation afterwards. So sliding 3 and 4. Sliding 2 and 5. Sliding 1. Next, from the plan, you're going to, from the true shape, I'm going to move that up a little bit more. You're going to bring out those 5 points onto the relevant lines. 2 and 5 onto the line 2 and 5. 3 onto the relevant line 3. 1 onto the relevant line 1. Now my set square moved on me, so just bear with me for a second. 4 onto the line 4. And finally your last point. Okay, so it looks funny, but I can see 1 is jointed to 3 and so on. If you need to label them, you can. And the only reason you'd label them is so that you know that you're going to join the correct points together. but you're just skipping every second point and joining each second point to the relevant line. When you've got your desired shape, or you've joined all 5 lines together, you can start putting in heavy, what's meant to be in heavy, and what's meant to be in light, and so on. Okay, so I've transferred the star, and you imagine that you're looking down on top of this and you can see the star. Lovely. Now I need to transfer that star onto the actual elevation, and that will complete the question. So like you transfer anything from elevation, you have to bring them up vertically, so you need your T-square. Now, again, if you need to, you can label these. Okay, so I've brought up all 5 points. And then you're wondering, how do you get heights? Well, if you remember, when I went out to my first auxiliary, I took this height from the elevation. So the heights that are in this view are the same in this view. So I can take the height of 1 and strike it on the line 1. I can take the height of 2 and 5 and strike it on the line 2 and 5. Take the height of 3 and 4 and strike it on the line 3 and 4. When I have the 3 heights moved, now it relates to 5 points, but it is 3 heights because there's 2 of them in line with each other, like 3 and 4 and 2 and 5 are in line. So 3 on the line 3, so that's 3. And don't forget, you're taking it from the ground line as opposed to from the top of the step. Take 2 and 5 next. And then finally take the height of 1. Okay, and transfer the heights to the relevant lines. So this will be the same height. I just need to double check one of the points because I can't actually tell because there's so many lines going on. So that's a point. That is a point. See where the other side is, which is there. Okay, so I've found all 5 points up in my view. All I need to do now is finally join them together, and then once I've that done, put in heavy what needs to be in heavy. Okay, so there, oh, have I missed a line? Looks like that line is a little bit lighter. Okay, so that is it done. You didn't have to draw the circle, but there would have been a lot of work in drawing the circle because you would have had to find 12 points on this, bring the 12 points up, which can happen, by the way. Rotate the 12 points around, bring them down, find your elliptical shape in plan, find your elliptical shape in elevation, and then you'd have it all done. But no, that's a really good question to, again, practice just the basics with the vertical and horizontal trace. You didn't have to really find any points up here initially because the vertical and horizontal trace was the first part of the question. Getting the true shape is another good thing. But if you have a shape that has to be put on the sign, you always have to do it on the true shape. So it may not tell you draw the true shape, but if you're asked to put a shape on it, you have to do it in a true shape. So you'd have to do all of that, then put on the true shape and then work back through all of the views in order to finish it off. Okay, so get that done for me today. Don't forget to put a thumbs up on the comments in Teams. That's your attendance for today. You're not joining me live. Okay, so just remember to do that.